Good morning. My name is Dan Schrader, and I'm here to talk to you about optimizing and securing your container-based applications with F5 Container Ingress services. Now, before we jump into F5 solutions, let's talk about containers and about how to apply advanced network services such as security and load balancing to your container-based apps. Containers are, of course, all the rage, and they solve a big problem. Namely, how do we get software to run reliably when moved from one computing environment to another? So what is a container? A container is a standardized way to package software and its dependencies. A fundamental aspect of containers is that they isolate applications from one another. And to increase portability and to reduce footprint size, containers do share the same OS kernel. Containers are thus designed for mobility, and they can run in a wide variety of environments. Containers are a lightweight alternative to full machine virtualization. They provide many of the benefits of loading an application into a virtual machine, as the application can be run on any suitable physical or virtual host without worries about dependencies. However, containers are lighter, they're more portable, and they're designed to make it easy to build modular, modern, next-generation applications. Why do companies use containers? Well, they use them because they're faster to spin up and spin down than virtual machines. They're also lower overhead than virtual machines. They're relatively easy to manage, they scale better, and they're a better fit for next-generation applications. Now, you can't really talk about containers without talking about Docker. Many organizations use Docker to package applications and libraries and configurations into containers. It makes it easy to containerize your software. So Docker is an open platform for building, shipping, and running distributed applications. Docker gives programmers and development teams and operations engineers the common toolbox that they need to take advantage of the distributed and networked nature of modern applications. But Docker doesn't help you manage large numbers of containers. For that, you need an orchestration system. Orchestration systems provide lifecycle management of containers. That is, it helps with those key functions such as assuring high assurance, provisioning and deployment, scaling or removing containers, moving containers from one host to another, allocation of resources between containers, load balancing of service discovery between containers, even health monitoring. Now, before we talk about container ingress, there are some Kubernetes basics that you should know. Pods are the basic building blocks of Kubernetes. Each pod includes one or more app containers, storage resources, a unique IP address, and specifications on how the container should be run and managed. A pod will logically contain one or more containers that should be managed as a single entity. A pod may include both the containers, let's say, for your Node.js app, as well as a different container with the data to be published by the Node.js web server. The containers in a pod share an IP address and port space and are always co-located, co-scheduled, and run in the same shared context on the same node. And that leads us to nodes. A pod always runs on a node. A node is a worker machine in Kubernetes. A node can have multiple pods. Nodes are always managed by a master. And nodes always have container runtime, which pulls, unpacks, and runs the containers, a kubelet, that is an agent that runs in each node and ensures the containers are running. It manages the pod lifecycle, and a kube proxy, which enables the Kubernetes service abstraction by maintaining network rules on the host and by performing connection forwarding. Now, a cluster consists of at least one cluster master and multiple worker machines, called nodes. The cluster master runs the Kubernetes control plane processes, including the Kubernetes API server, as well as the scheduler and core resource controllers. The master is the unified endpoint for your cluster. All interactions with the cluster are done via Kubernetes API calls to the Kubernetes API server. At the highest level, there are 4 different types of communications or networking that can go on as part of your Kubernetes environment. Container to container, pod to pod, pod to service, external to service. Throughout this, Kubernetes follows an IP per pod model, where each pod gets assigned an IP address, and all containers in a single pod share the same network space and IP address. You can use that IP address for networking, but since pods can go up or down, this isn't always reliable. Instead, you can use a Kubernetes service. So of these 4 types, the first 2 can be grouped as pod networking, and the second 2 types of communication can be thought of as service networking. A few rules about networking in Kubernetes. Containers can communicate with all other containers without NAT. Nodes can communicate with all containers without NAT and vice versa. The IP address that a container sees itself as is the same IP address that others see it. Now, this creates a simple flat network across your Kubernetes cluster. However, external or north-south networking requires something else, an Ingress controller. So let's talk about Ingress services. Ingress services in Kubernetes define how north-south traffic is routed. It provides a reliable connection between Kubernetes services and the outside world. Ingress is generally implemented by an external load balancer, and which one you should use really depends on what level of security and availability you require, and of course, on your budget. So let's talk about using F5 for Ingress control and advanced application services. F5's Container Ingress Services was previously called Container Connector, and F5 has fully embraced the open source model. So this is a native open source Ingress control tool for configuring and managing F5 services delivered via a big IP physical or virtual device. The service enables self-service selection and orchestration for application services. It allows you to scale and secure applications through automated event discovery and service insertion. And it supports the F5 Application Services 3 extension, AS3, to configure layer 4 through 7 network services through simple declarative APIs. Now honestly, if you have a single non-production app and security isn't a major concern, you may not need a big IP. But there are substantial advantages of using big IP for application services. To start with F5 you get access to advanced services such as the industry's leading tools for web application firewall and DDoS mitigation. You can also improve performance through TLS offload, and you can reduce latency and the number of hops by routing traffic directly to the app front end. You can leverage advanced traffic management and application acceleration. You can enable IPv6 clients to use IPv4 containerized apps. With Big IP, you have support for hybrid container virtual machine environments and hybrid cloud environments, and it allows you to do so and have consistent security and consistent authentication policies no matter where your compute occurs. Finally, we allow use of declarative AS3 extension to configure Big IP, which allows you to specify what it is you need without being a TMOS expert. The use cases for Big IP to deliver network services to your container-based deployments are really only limited by your imagination. They include frictionless application service insertion, auto-scale and secure cloud container applications, streamlined application migration, advanced container application protection with F5 security solutions. Extensive professional documentation is available on clouddocs.f5.com or through the Kubernetes concepts on kubernetes.io. Finally, F5 is committed to helping you and your customers get the most out of their network. We offer global support and professional services who can help you architect, implement, maintain, and optimize your F5 implementations. Speak to your F5 sales representative to learn more. Thank you for joining us in this webinar today about Kubernetes and F5. We look forward to working with you.